Hello everyone, welcome to my channel again. So today we'll discuss one problem from Leetcode, that is 997, find the town judge. So the problem statement is saying, in a town there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. Suppose there is 1 to n persons in a town and secretly one of this guy is a town judge. The town judge trusts nobody. This guy don't trust anyone. Everybody except from the town judge trust the town judge. So these guys, they actually trust town judge, but town judge don't trust anyone. Okay. There is exactly one person that satisfied properties 1 and 2. That means either this person will be a town judge or a normal guy, and only one town judge is there. You are given trust, an array of pairs trust I, that is A comma B. That means A trust B. Okay. If the town judge exists and can be identified, return the label of the town judge, otherwise return -1. So here if you take one example, n equal to 2, that means two persons are present in a city. Trust array saying 1 trust 2, that means 1 trust 2. So what will be the output here? Who is the town judge? That is 2. Why? Because here this condition is getting satisfied. Because 2 don't trust anyone and 1 is the only person in the city other than the town judge who trusts 2. If you take another example, here it is 1 trust 3 and 2 also trust 3. So who will be the town judge? 3 will be the town judge because 3 don't trust anyone. Apart from 3, everyone trusts 3. If you take few other examples, you can check. Here 1 trust 3, 2 also trust 3, and 3 also trust 1. So in this case, what will be the output? The output will be -1 because there is no town judge. Why? Because 1 and 2 trust 3, but 3 also again trust 1. If he is a town judge, then he will not trust anyone, right? So that's why all these conditions are not getting satisfied. So example 4, if you check here, 1 trust 2 and 2 trust 3. Okay, so 1 trust 2, 2 trust 3. Here who is the town judge? Here no one is town judge because 3 is trusted by 2 but not by 1. So that's why you will not get a definitive answer and it will be -1. N equal to 4. So here if you check 1 trust 3, 1 also trust 4. Then if we check 2 trust 3. So 2 trust 3, 2 trust 4 also, and 4 trust 3. So who will be the town judge? 3 will be the town judge because 3 is trusted by everyone apart from 3, that is 1, 4 and 2. Okay, and 3 don't trust anyone. So if you look all these examples, if you check, this is actually a entry level graph problem, you can say, because when we are drawing the graph structure from this trust array, then things are clear for us. And what we can observe is who will be the town judge, where you know about like in degree and out degree of a node, right? In degree means how many connections are coming towards that node, and out degree means how many connections are going outside of the node. So here for 3, the in degree value is how many? 1, 2 and 3. And what is the out degree value? That is 0. So if for some node the in degree value is n minus 1, that means except that person, if everyone else trust him. So that is n minus 1, and the out degree value is 0. That means that guy don't trust anyone. Then that node will be our answer. So if you check here, we thought like 3 will be our answer, but in this case, in degree value is 2, but the out degree value is 1. So that's why it is not satisfying. Here, no one is satisfying this condition. But here if you check this 3, they have a in degree value of 3 and the out degree value is 0. So the condition we will check is in degree will be n minus 1 and out degree will be 0. Or else what we can check is in degree minus out degree will be n minus 1. Same thing, right? Now we'll see the encoding how we can do this. So let's take one example. This is our trust array and these are the number of person, that is n equal to 3. If we form a graph out of it, then it will be look like this. 1 will trust 3, 2 will also trust 3. What we have to do is we have to form a degree array of length n. So we have to form a degree array of length 3 here. Initially all this value will be 0 when we will create this array. Now if in degree is there, then that time we will do a plus 1, and if out degree is there, that time we will do a minus 1. So for the first thing, if you check for 1, one node is going outwards. So for 1 it will be minus 1. So here as the index is starting from 0, 1, 2, that's why we are considering 0 as 1 and 2 as 1 and then 3 as 2. Okay. So for 1 as it is going outwards, that's why it will be minus 1. For 3 it is coming inside, so it will be plus 1. So for 3 it will be plus 1. 3 means 2 in this case because of the index position. For 2 what will be the case? For 2 it is going outwards, so it will be minus 1. So it will be a minus 1. For 3 the node is coming inside in this case, so it will be a plus 1. That will be 1 plus 1 and it will be 2. And we finished traversing this array. Now we have to check for which node the in degree minus out degree, means the value present here is n minus 1. So if we check for this node 2, the in degree value is n minus 1, that is 3. Minus 1, 2. So we have to return this plus 1 and the answer will be 3. Because of this index we are doing a plus 1. So if we check the code now, find judge, here we are passing this int n equal to 3, then the trust array. So we are forming a degree array of length n like this. Then we are traversing through the trust array. And if we check that in the degree array for the like second position like this one, it is coming in degree, right? Because 1 is pointing towards 3. So for that position we are doing a plus plus. Here minus 1 is because of this index position. For same case, for degree trust I0 means the first one, the out degree value will be reduced, right? So it will be minus minus. After calculating the in degree and out degree, we are checking which particular index position has the degree value as n minus 1. When we got that one, we are returning I plus 1. Here if you check, the same thing we are doing. And if we are not getting anything which is satisfying this part, then we are returning minus 1. So what is the time complexity involved? As we are doing a linear operation twice, so it will be O of n. So now if we submit this solution, it is working. Thanks for watching.